Welcome to Pomodoro Joe for Saturday, August 26th, 2023. Today we're looking at LeetCode problem 646, maximum length of paired chain. This is a medium problem. You are given an array of n pairs, where pairs index I is equal to left sub I, right sub I, and left sub I is less than right sub I. A pair, P2, which is equal to array CD, follows a pair, P1, which is equal to array AB, if B is less than C. All right, so that means if the second value in our first pair is less than the first value in our second pair. A chain of pairs can be formed in this fashion. Return the length of the longest chain which can be formed. You do not need to use up all the given intervals. You can select pairs in any order. All right, then we have some examples. So 1, 2, 2, 3, 3, 4. So it looks like we can do 1, 2, and 3, 4. Yep, so that gives us 2. Now notice it's B has to be less than, strictly less than C. So this has to be strictly less than this. In this case, that means we have to skip this middle pair. Example 2, pairs 1, 2, 7, 8, 4, 5. So these aren't sorted, so this makes me think we'll probably want to sort our pairs before we start working with them. So we can do 1, 2, 4, 5, 7, 8, and that gives us 3. All right. Seems pretty straightforward, so we'll put 25 minutes on the Pomodoro timer, and we will get started. So we'll start with our result, set it equal to 0, and we will return our result at the end. All right. Now let's see. As I mentioned, we'll probably want to sort our pairs. So we could sort our pairs. We could just do sorted pairs. Let's do this. And that's equal to sorted. And we'll pass in pairs. Now this will sort by the first value first and then the second value second. So it's going to sort by A and then B. And it will sort in increasing order. So we would end up with something like this. All right. But I think this might present a problem. So we sort by A first. So what if we had something like this? Let's say we had 1 and then 1,000,000 or some very large number. And then we had a second pair which was like 2 and 3 and then 4 and 5. Now if we sorted, this would be sorted in the correct order because we have 1, 2, 4. That's all good. But when we look at this very first value, we might think this will be part of our chain, but it's going to extend all the way up to some very large number here. And that's going to block out our use of these other two values. You can imagine our number line as our search area for building our pair chain. Now, in our search area, we can use any pair that basically comes after our biggest value, our largest value in our current chain. So our largest value in our current chain will essentially define our search area. So anything that came before that largest value is no longer a valid pair, or you can't use that in our chain. So as soon as we grab this pair and we go up to, let's see, what is this? 1,000,000? Now anything before 1,000,000 is tossed out. We can't use it. So our search area becomes 1,000,000 and above. So if we just look for our right values, those are going to be the larger values in our pairs. So our pairs are going to have a left and a right. The right value is the largest value in that pairing. So if we look at just the large value of our pair, that's going to be the largest value that defines the rest of our search area. So we'd like to keep that as small as possible so that we can keep our search area as large as possible. So instead of sorting by just our A and B, or our left first and then right, let's sort by our right and then left. Or we don't even need to include the left. We can just sort by right because we already know that left will be lower than our right. So to do that, we say our key will be a lambda function. And that will be a lambda function of x. So basically this will just go through each one of our pairs. Now our lambda is a function that's not really a defined function. We're defining it in line here. X is the parameter that we're passing in, so that's going to be one of these pairs. And so for our lambda x, we'll define that as the second value in x. So that's x at index 1. So that's going to be giving us this right value. So now we'll sort our pairs by our second value, this right value, and it will be in increasing order. So now we can go through every pair in our sorted pairs. And let's see, I guess we need to keep track of our largest value so far. So let's keep track of that. I'll call it the max right. This is the maximum right value we've seen so far, and we don't have any to begin with. So let's first check. So if we don't have our current maximum right value, well then this pair will define that current maximum right value. And it's going to be the lowest one so far because we've sorted by our right values. So in this case, our max right will just be this pair. So it'll be this pair's right value, which is index 1. Cool. And our result can be equal to 1 because now we have one pair. And we'll just continue. Okay, if we have a maximum right so far, now we have to check this pair. Can this pair actually be part of our chain? Well, we know it can be part of our chain if its first value, its left value, is greater than our current maximum right value. So if this pair's left value is greater than our current max right value, then this can be part of our chain. So we'll add this to our chain, and to do that, we'll just set our max right equal to this new pair's right, and we'll increase our result by 1. Cool. And then when we get to the end, we can return our result. I think this should do it. Let's run that and see how we do. And we pass. Let's see if we can pass all the tests. And we pass. And we do really well, actually. We beat 95% for runtime and 14% for memory. So that's pretty great. And it looks like, well, we're way up here, but it looks like a lot of people are up here. So this is pretty standard. All right, one thing we could do, I don't think it's going to give us much of a gain, but we could early out here. We could do something really simple. If we don't have any pairs, then we'll just return 0. All right, so if we don't have any pairs, we'll return 0. Otherwise, we can do everything else. That gives us one little bit of a gain because we have an early out. The other thing we can do is we know when we get here, we already have some right value. We have at least one pair because otherwise we would have returned already. So instead of having to do this check every time, we could actually do, this is sorted pairs at index 0. And we'll take the right value from our sorted pairs at index 0. And our result, we can actually start at 1 because we've already passed our first check up here. And that means we can get rid of this first conditional. And then let's see, we might have to go from sorted pairs from 1 to the end, just so we don't do the same pair more than once. Let's see if this gives us a better answer. Probably not, but it's worth a shot. All right, and we pass, and we get slightly worse. We're at 94% for runtime, do a little bit better memory though, 35% in memory. So it's a little bit worse in runtime, a little bit better in memory, a little bit cleaner code, a little bit shorter. So it's up to you, whichever you prefer. And I'll do one last thing, maybe give us that percentage back. We'll just reduce some of these. All right, we can get rid of this because we already defined it below. Okay. All right, so this is just a little bit cleaner. All right, and we do a little bit better. So this time we get a 96% for runtime and a 65% for memory. So that's a big gain. All right, so this is probably the best answer so far. Okay, well that's it for me. I hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.